All right, here we go. We're going to look at question number 2 of the 2025 AP Calculus AB exam. This was not a common question. This was AB only. This is a calculator active question. I have not yet read the question, so you're going to get to see me solve this in real time and process the problem without any pre-rehearsed, that's redundant, thoughts. So if I make any mistakes, please let me know in the comments. And if you like this, go ahead and click that like button and subscribe. So let's take a look at this. Looks like area volume. All right, so number 2, the shaded region R is bounded by the graphs of that and that, F and G. I am going to go ahead and define those in my calculator. So f of x is x squared minus 2x. That's a really clean function for this to be a calculator active question. G of x is x plus sine pi x. That is also a pretty dadgum clean question. Sine of pi x. I'm going to go ahead and graph those. So I'm going to go to my calculator. Let me clear this out. This is my stuff from question number 1. So let's clear doc B. I said doc B, escape. Would you just clear the calculator? There we go. All right, and so let's start defining. So f of x colon equals, I don't need a matrix, x squared minus 2x. I didn't hit equals, colon equals. There we go. And g of x is x plus the sine of pi x. P pi x, x plus sine pi x. I am in radian mode. Everything is good to go. And question A is really nice. Find the area of this and show the setup for your calculations. And this is an interesting one because you should have these skills to actually do this without a calculator. However, why? It's a calculator active question. So the limits of integration are 0 and 3. Very nice of them to give you that intersection point. They didn't have to do that. And my top graph is the graph of g of x. My bottom graph is the graph of f of x. So it's going to be g, oh, that was a really messed up g. G of x minus f of x dx. And the gods of math would prefer you to write that as the entire difference times the dx. AP readers generally don't count off for that, but why tempt fate? So I'm going to punch that in the calculator. 0 to 3 of f minus g, or g minus f. Shift plus. 0 to 3 of g of x minus f of x dx. Enter. And you can either present your answer as 2 over pi plus 9 halves, or you can give the decimal approximation of 5.1366. You only have to be accurate to the third decimal. I like to write 4, and in this particular question, you could truncate that by writing 5.136, or you can follow standard rounding procedure and present 5.137, or you can write 5.1366, and that's fine as well. All right, number B, the region R is the base of a solid. For this solid, cross sections perpendicular to the x-axis are rectangles with a height x and base and region. So the height is x. Interesting. Okay, so this is a volume question, and all volumes in AP Calculus are computed by integrating the area of the cross section. So if this is a rectangle, the area of a rectangle is base times height. This is a dx problem. They tell you cross sections are perpendicular to the x-axis. We are still going from 0 to 3. All I need to do now is get my base and my height as functions of x. The base is the dimension that you would draw in the region R, and the distance from top to bottom is top minus bottom. So my base would be g of x minus f of x, and they tell you the height is just x. And so I'll take all of this, roll it into a single antiderivative, 0 to 3, of x times g of x minus f of x dx. And if you are using, I guess it depends on which calculator you are using, but the way I wrote that can present issues for the TI Inspire. So if I write 0 to 3 of x and then open parentheses g of x minus f of x dx, I'm going to get an issue because when I do x open parentheses, the calculator thinks I'm writing something like f of, it's reading that as x of g of x minus f of x. So I got to put a multiplication dot there. That looks good. Control, do I want to, that's not bad. 3 over pi plus 27 over 4. Plus 27 over 4. Or you can present that as the decimal answer, which would be 7.7049. Number C, write but do not evaluate an integral expression for the volume. This is just a good old classic area volume question. All right, rotating this around the horizontal line, y equals -2. So this is going to create a washer. This will be a dx problem. And the volume of a washer is pi, antiderivative of big R squared minus little r squared. We are still going from 0 to 3. I need to get my radii of that washer in terms of x. And the big radius is going to be the distance from the graph of g of x down to the horizontal line y equals -2. So big R is g of x minus that bottom line, -2, or g of x plus 2. Little r is going to be f of x minus -2. And I'm just doing top minus bottom thought processing right there. And so we'll roll that into a single antiderivative. Watch your parentheses here. That's going to be 0 to 3 of big honking parentheses, the quantity of big R squared, so g of x plus 2 squared minus the little r, which is f of x, plus 2 squared times the dx. And again, the gods of math would like for you to put that big integrand in brackets or parentheses. And let's cover our bases, make sure that we have that there. I think that is it because we are not evaluating this. All right, and then number D. It can be shown that g prime is equal to this. Find the value x at which the line tangent to the graph of f is parallel to the line tangent to the graph of g. So we need their derivatives, which would produce the slope of the tangent at any given x coordinate, to be equal to each other. So we need f prime of x to equal g prime of x. F of x is x squared minus 2x, so the derivative of that would be 2x minus 2. G prime, they provided for us, that's kind of nice, 1 plus pi cosine pi x. And we will solve that in the calculator. I will graph both of those and find their intersection on the interval 0 to 1. So pay attention to stuff like that. So onto my graph screen. So we have 1 plus pi times the cosine of pi x. And that is g prime. F prime was 2x minus 2. And we want the intersection from 0 to 1. That would be this one right there. So I'm going to go menu, analyze, intersection, drag across there, and the intersection point is 0.6758. X equals 0.6758. Make sure I answer the question. It can be shown that g prime is this. Find the x value at which the line tangent to f is parallel to the line tangent of g. There we go. We are done with question number 2 of the 2025 AP exam. Again, if you think I made any mistakes, point them out because I very often do. And I will be happy to answer those for you. All right, on to 3.